Alrighty, welcome. So today we're going to be having a look at sketching quadratics without technology. And the next one, I'm going to be showing you how to do all of this with your calculator, which is going to speed up the process a lot. So what do we want to look for? We want to find all intercepts. So that's 1, 0, or no roots, and then the one Y-intercept. We want to find the axis of symmetry, the turning point, and we're going to have a look at a few examples of how to do this. So let's start off with a nice straightforward example. Alrighty, so y is equal to x squared minus 4x plus 3. So, step 1, x-intercept is when y is equal to 0. Let's do the tough bit first. So we've got 0 is equal to x squared minus 4x plus 3. Well, hey, let's try factorizing it. T-chart times to 3 adds to negative 4. So it could be 1 times 3 or minus 1 times minus 3. And hopefully we can all see it's going to be minus 1 and minus 3. Decomposition, minus x minus 3x plus 3. Factorize bit by bit. And bring out the x minus 1, x minus 3, and we've got our two solutions using null factor law. So x1 is equal to 1, x2 is equal to 3. Therefore, we've got our two x-intercepts, which are 1, 0, and 3, 0. Alrighty, up next, y-intercept is when x equals 0. So we get y is equal to 0 squared minus 4 times 0 plus 3. It's equal to 3. So we now have our 1-intercept, which is going to be 0, our 1 y-intercept, which is 0, 3. Alrighty, so looking pretty good so far. Next go, axis of symmetry and the turning point. So for the axis of symmetry, it's going to be halfway between the two y-intercepts. So, the two x-intercepts. So x is going to be equal to b plus c over 2, which is just our two intercepts, which is 1 plus 3 over 2 from over here, 4 on 2, which is 2. Now, since that's our axis of symmetry, x equals 2, that also tells us it's going to be the x-coordinate of our turning point. So our turning point is going to be 2 comma something, and now we just need to substitute it in. So sub x equals 2, we get y is equal to 2 squared minus 4 times 2 plus 3, 4 minus 8 plus 3 minus 1, and so the turning point is 2, negative 1. And now we can sketch. We have everything we need. We know the y-intercept, we know the x-intercept, we know the axis of symmetry, and we know the turning point. Now we should also know that it's going to be concave up, but I think it's always good to visually check as well. So the y-intercept is at 0, 3. The x-intercept's at 1, 0, and 3, 0. The turning point's at 2, negative 1. And we can smoothly connect this up with our nice quadratics shape. Give it a label, x squared minus 4x plus 3. Now I've used everything to scale, but it's good to just mark things on. So that's going to be 1, 3, 2, negative 1. And up here is going to be 0, 3. Alrighty, and so that is a quick sketch. Let's look at one more. Alrighty, let's have a look at this one. So once again, let's start with the x-intercept, which is when y is equal to 0. We get 0 is equal to negative 3x squared minus 12x minus 13. We've got to factorize this. So step 1, check your t-chart. So it's going to be timesing to, what's that going to be? It's going to be 39, adding to negative 12. Well, 39 doesn't have that many factors. It's either 3 times 13, negative 3 times negative 13, 1 times 39, or negative 1 times negative 39. That's it. Those are all the options. And you can quickly see that that's going to be 16, that's going to be negative 16, that's going to be 40, and that's going to be negative 40. And none of those work. Therefore, T-chart was a waste of time. I should have reached for the discriminant instead for the quadratic formula. So we've got b squared take 4ac, which is going to be negative 12 squared take 4 times negative 3 times negative 13. Negative 12 squared is 144. So it's looking pretty likely it's going to be positive until you look at the next bit. Negative 4 times negative 3 times negative, it's going to be a negative. 4 times 3 is 12. 12 times 13 is going to be 156. Doing the subtraction is going to be negative 12, which is less than 0, therefore no solutions. Which means roots, no roots. This will not touch the x-intercept, the x-axis at all. Alrighty, next up is the y-intercept. Y-intercept happens when x equals 0. Alrighty, x equals 0, so we get y is equal to minus 3 times 0 squared, which is fascinatingly 0, minus 12 times 0, which is also 0, minus 13. 0 minus 0 minus 13 is minus 13. And so we get the y-intercept is going to be 0, negative 13. Now, our current strategy for finding the turning point has been to use the 2 roots. But this one doesn't have any roots. So how are we going to find it instead? Well, there's one other thing we can do. There's actually 2 ways we can do it. Option 1 for finding the turning point, which the turning point's also going to tell us the axis of symmetry. Option number 1 is we use this formula. So this is a formula you probably haven't seen before, but it can be used, which is just minus b on 2a. The x turning point, so the x coordinate of the turning point is just equal to minus b over 2a. That's one option, but that's another formula you have to memorize. Option number 2 is we go through the process of completing the square. And we'll get the same answer either way. So let's do the easy way first. So substitute in b and a, so we get minus 12 over 2 times negative 3. We get 12 on negative 6, sorry. 12 divided by 6 is 2, negative 2. So the x turning point is negative 2. Therefore, the y turning point is just going to be when we sub it in. So sub in x equals 2, y is equal to negative 3 times 2 squared minus 12 times 2 minus 13. Minus 3 times 2 squared. 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 times 2 is negative 24 minus 13. Oh, sorry. Didn't sub in the negative here, so this should actually be positive 24. So in this case, negative 12 plus 24 is 12. 12 minus 13 is negative 1. And so our turning point is 2, negative 1. So that's option 1 for doing the turning point, is using this formula, which has not been shown before. Option number 2 is let's complete the square. Oh, let's do it off to this side. Complete the square. Now, if you've had a bit of practice with this, it shouldn't be too difficult. This is a relatively nice one, so it's minus 3x squared minus 12x minus 13. Got to get rid of that minus 3 at the front. X squared plus 4x minus 13. Do the usual trick for completing the square. So we're going to add half and square root of 4. Four on 2 squared minus 4 on 2 squared minus 13. Use the whole actual point of the completing the square method. So we get x plus 4 on 2, which is just 2 squared, minus 4 on 2 squared, which is just 2 squared, minus 13. So these three terms collapsed, and that term stays. Now we need to expand these brackets, minus 3 times that, minus 3 times that. We get y is equal to negative 3x plus 2 squared, negative 3 times negative 4, well, negative 2 squared, which is negative 4, is positive 12 minus 13 minus 3x plus 2 squared minus 1. And you can quickly see, right, that this is already in turning point form, therefore the turning point can be read off, and the turning point is equal to negative 2, negative 1, which is exactly what we got over here if I'd remembered my negative sign that I keep seeming to forget in all of these steps over here. Alrighty, so those are the two different options of finding it, and you'll see that you get the same answer either way. Now that we know the turning point, the y-intercept, and also we know the axis of symmetry, x is equal to negative 2, axis of symmetry. Now we can sketch. So, axes. It does not touch the x-axis. And it's got its one usual y-intercept, so the y-intercept is going to be negative 13. And the turning point is going to be at negative 2, negative 1. And we can see that then the shape is going to be something like this. Concave down, axis of symmetry at x equals negative 2. Now for sketches, you don't have to worry about getting your axes 100% right, but it's always going to make your life a little bit easier if you do make it look nice and pretty. And lastly, but not least, make sure you label your graph. Alrighty. And that's how you can sketch a quadratic. See you in the next one. Goodbye.